Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 215. That is kth largest element in an array. Okay, so let me do the question first. Given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay, so we are given array nums of integer, so we are given an array of integer nums and an integer k, and we have to return the kth largest element. And there is a note that is saying it is the kth largest element in the sorted array, not the kth distinct element. So we don't have to tell like if this is the array, so we don't have to tell like if 2 is given, so we don't have to tell the second last element. We have to tell the second largest element that is present in the array. So in this case, 6 is the largest element and 5 is the second largest element. So we have to return 5. We don't have to return 6. In our second example, we have this array and k is given as 4. So the largest element is in the array is 6 and the second largest is 5, and the third largest is also 5, because if you sort the array, our third largest element would be 5, not the 4, and our fourth largest element would be 4. So we have to return 4, not the 3, because don't have to do it like 6 is the largest element and 5 is the second largest, 4 is the third largest, and 3 is the fourth largest. We don't have to do that. We have to tell the uh, fourth largest element in this sorted array. Okay, so in our our constraints are given that 1 is less than equals to k is less than equals to nums dot length is less. Okay, so it is basically saying nums of array would be always be greater than 1, and k would lie something between 1 and nums of length, so it wouldn't exceed the length of the array. So let's understand, let's visualize or see the solutions. And for we'll do solution for this example. So suppose this is our array and we are given 2. So we have to return the 5. So the most basic or the brute force approach would be something like we could do is that we should iterate over the array and delete the k minus 1 elements. Like in this example, if we have to delete like the largest element, okay, we have to delete the largest element k minus 1 times. So here k is 2, so we have to delete the largest element 1 time. So what I mean to say is that we have to iterate over the whole array, and we found that this is the largest element. So we have to remove this element. So we have to remove this element and uh, bring next elements to its place. What all the elements that are after that element, we have to move them one place left to their own original place, and then we can return the largest element. So suppose if in this case it is given 2, suppose it would be something like if it is given 4 or 5, like we have to do the fourth largest element. So what we have to do is we have to iterate over the array first time and remove this and move all the elements to its left. Okay, then we have to iterate over the array again and remove the second largest element, and then we have to iterate over the array and remove the third largest element, and each time we are removing, we have to move all the elements on the left of that element to their all the elements right to the right of their to the right side of that element to their left, and each time we are removing the element. As now we are because we have to tell the fourth largest element, so we have to do it like 3 times. We have to remove 3 elements, and the next largest element is the fourth largest element. So this is the most basic or the brute force approach. So this approach would take something key O of k and time, because we have to do like k times. We have to iterate over the array of size n, so it would take something O of k and time complexity. So the better approach would be if we could sort the array, because sorting array would take us O of n log n time, which might be better than k log n. So if we sort the arrays, then we can directly return the element at the arrays dot length minus k time. It would take O of log n log n time. Okay, suppose if we have to, if we to sort the array, we need only O of n log n time in the case of merge sort or something like that. But after sorting array, we can directly return the like element or the element at the array, or element of the array at length minus length of array minus k times, because yeah, suppose in this case we have to remove 5, and if the length of the array is 6, and if we do k minus 6, then that 6 minus 4, that is 6 minus 2, then we'll get the 4, and we can return the element that is present at the fourth index, and that would be our correct answer. Okay, so this is the second approach, and it would take something O of n log n time to store, and we can then directly return the element. So it would take O of n log n, which might be in most of the cases it would be better than O of k n, because we are taking O of n log n in the large arrays. So there is one more approach that is basically we can use a heap, or like priority queues that uses the heap function. So suppose this is our array, like this is our array 3, 1, 5, 6, and 4. So whenever we put it, so let me tell what the priority queue is initially. So all the queues, like the queue follow the principle of FIFO. Let me write it. Queue follow the principle of FIFO. That means first in, first out. But the priority queue didn't follow the principle of FIFO. It used the min heap, that is heap function. It uses the heap function, and heap function for obvious, heap function uses either min heap or max heap, but the priority queue by default use the min heap function. So priority queue, let me write it. Priority queue uses the heap function or min heap function. So what is min heap function? That means it doesn't like align the elements in the order. Like it isn't if we put the elements of this array into the queue, it would be same like the array if we start retrieving from the front. But for priority queue, if we start keep putting the elements of the array, it would follow the concept of min heap. That is, all the elements would be automatically get sorted. This element would be inserted in this fashion. Suppose 1, then 2, then 3, then we can do it at 4. Next element would be 4, and then next element would be 5, and then next element would be 6. Okay, so this if we use priority queue to like put all the elements in the priority queue, the elements wouldn't be they are inserted in the fashion. They would be something like this. They would automatically get sorted, and this addition and deletion from the priority queue takes O of only log n time. It doesn't take O of n time to sort the elements, or because priority queue, it doesn't follow the principle of FIFO. It follows like some priorities, like priority, and the element the most prior element would be at the front of the priority queue. So the next element we are going to pop or peek would be the most prior element. And priority queue in Java follows min heap property. That is, the smallest element would be at the top or at the front end, and it shouldn't be like it shouldn't always be like all the rest of the elements would be sorted. It might be that 6 would be here, and 4 would be here, and something 2 would be here, 5 would be here. All the elements, the rest of the elements could be anywhere, but the smallest element would always be at the top of the queue. And whenever we retrieve the element, we get the smallest element in our priority queue. So if we suppose put all these elements in our priority queue, it would be something like, suppose initially we put all the elements in our priority queue, so the smallest element would be at the top or at the root, but the rest of the elements could be anywhere in the tree, because priority queue follows heap, and heap implements some heapify function which doesn't cares about the sorted order. It just gives the priority to the elements. Watch, if heap is min heap, then always the minimum element would be at the top, and if it would be like max heap, then the largest element would be at the root. Okay, so initially suppose we put all our elements in our heap, so it looks something like this, and then if we keep on deleting the elements, the root elements, then it would convert something like this. I mean to say is that always the smallest element would be at the root. So suppose initially first time we delete 1, and then second time we delete 2, the third time we delete 3, and the fourth time we delete. So what we have to do is that what we have already done in our array, like sorted array. So we have to delete like length minus n time to get our like length minus k time. Sorry. So if we delete length minus k elements, like if we delete length minus k time, we'll get our, like, if we suppose length is 6 and our k is 2, so if we delete k minus 2, if we delete 4 times, we'll get our, like, kth largest element. So in this case, it would take log n time to insert the elements, or and log n time to insert the elements, and O of n time of, or O of k times to delete these elements. Okay, O of n minus k times basically to these elements. So it is basically lesser than O of n. So it will be roughly something around O of n log n time. So first time we delete 1, 2, 3, and then we delete 4, then we get our, like, kth maximum element, or the second max largest element. So let me implement both of the solution, because it is also taking O of n log n time, and this one is also taking O of n log n time. So let me check which one performs better. So first, let us implement, like, sorting technique. Okay, so sorting solution is just two-liner, I think so. We could do is something like erase dot sort, which would take O of n log n time. In build function in Java, it uses something, I think so, merge sort or something, which uses O of n log n time, and we can pass our nums in here. Okay, so our array is sorted now. Now we can simply return our, like, nums dot length minus I can say, okay, k. Yeah, we can return this. Okay, let me check if it works or not. It seems to work properly, and let me now submit our code to check if it is optimal or not. It uses O of n log n time, I think so, and to okay, it is 55% faster, and it uses some memory. Okay, for sorry, it might be using some other temporary memory. Let me submit again to check if it is stable or not. It might be stable. I hope so. It should be stable. Okay, yeah, it is stable, almost stable. Okay, so let me implement our second solution, that is, like, using priority queue, and check whether it is doing better than arrays.start or not. So let me create our queue. Okay, priority queue of integers, I would say. I can name it as result or something. New priority queue. Okay, so this, and actually we can do is that we can change its order from, like, make it follow the max heap property instead of min heap property, but it would take O of log n, O of n time. So it would be same if you do, like, deletion from the array, or it would be like max heap. It would follow max heap. So now what I can do is iterate over our array and put the elements of the array in our priority queue. So what I can do is for, like, integers, something I can put integer values in our nums array. I can do is, okay, rest dot offer. This is the method to add the elements to the queue or the priority queue. Offer our values. Okay. Now what next we can do is now we can iterate over array for, like, length minus k time to retrieve the elements, and then we can return element. For suppose int equals 0, and I can do I is less than nums dot length minus k, I can say, and then we can do is I plus plus. And each time we iterate over, we have to remove like, the frontmost element to get to our, like, kth largest element. So we have to do is res dot pull function. I hope so. It is used to work to remove the elements from our queue, priority queue, and then we can return our, like, okay. So res dot peek function is used to get the, like, topmost element without retrieving it. Okay, so we are using res dot peek. Okay, so it should work. I think so. Let me check if it is working or not. It seems to be working. Let me submit to check optimality for this one. So it almost performed the same in the sense of time complexity, but in the space complexity it did a little bit better, but almost the same solution. So hope you enjoy learning, and if you have better solution you can comment in the comment section down below. And as always, thanks for watching.